Sorry for going old school with this, but we're going to do volume by rotation about a non-axis. So if you rotate about the x-axis, the thing that we're going to expand to today is if we rotate about a line parallel to the x-axis. But if you're going about the x-axis or a line parallel to the x-axis, you're going to have like horizontal rotation. And anytime you have horizontal rotation, so rotating about the x-axis or line parallel to the x-axis, everything is going to be in terms of x. Okay, so you'll have everything x, which means that you're going to have pi times the integral from a to b of your stuff squared with a dx at the end, and there's going to be x stuff in here. Okay, versus if you rotate about the y-axis or a line parallel to the y-axis, everything will be in terms of y. So if you're doing a vertical rotation, rotating about a vertical line, whether it's the y-axis or a line parallel to it, everything will be y. Meaning that we'll have pi times the integral from c to d, of whatever that is, squared with the dy at the end, and then there's going to be y stuff in here. Okay, so that's one of the first things that you should figure out if you're going to need your variables in terms of x or in terms of y. Then we have the difference, this is from before, that if we have a solid, meaning that there's no gap between the original region, which is why I want you to shade it, and the axis of revolution, you have a solid, and then you only need one r. Okay. Versus a hollow solid when there's space between the original region and the axis of revolution, which is why I want you to shade the original region. Then you need both big R and little r. Okay. Once you've established whether it's hollow or solid, you need to figure out what either just R is or what both big R and little r are. R. In any case, to find R, big R, you're going to draw from the axis of revolution to the outer curve on the original region, which is, again, a reason why it's important to shade your original region. And then to find little r, you're going to draw from the axis of revolution, just like last week, to the inner curve on the original region. Okay. And then you're going to do, just like we did with both area and the volumes preceding this, either top minus bottom or right minus left to figure out what big R and little r are. Okay? All right, let's do some examples. Starting with this one, this is paralleling your worksheet, guys, so you could just follow along with that. So again, always draw the region. I want to go y equals x squared. I'm going to go about y equals -1. So y equals x squared. Oh, what am I doing here? Hang on. Y equals x squared. Y equals 0. That's the x-axis, and x equals 1. That's right here. Okay, and I'm supposed to go about y equals -1. So let me draw a better picture of this. So we've got this little shape here, okay, and I'm going to revolve around the line y equals -1. Okay, that's what I'm rotating about. All right, so you see how you have this 1 unit gap here, right? So my region is above the x-axis, and then I have a 1 unit gap here, so I'm going to have another 1 unit gap here before I have the other side of it, and then I'm going to have symmetry, okay? And you can see that there's this gap here between the original region and the axis of revolution. That means I have a hollow solid. Okay, I also am revolving around a line parallel to the x-axis. It's a horizontal rotation, so it's going to be a dx problem. Now I'm going to figure out what my big R and my little r are. So I'm going to draw from the axis of revolution to the outer curve. I shouldn't have shaded it so dark on the original region. That's big R. And then axis of revolution inner curve on the original region. That's little r. So the inner curve here is just the x-axis, which is a little weird, but it's fine. Now big R is going to be top curve minus bottom. So big R is touching on top, just y equals x squared. And on bottom, it's touching the axis of revolution, which was -1, y equals -1. So I really have an x squared plus 1 here. And then little r is going to be, it's touching on the top, just y equals 0, the x-axis. Minus what's it touching on the bottom is the axis of revolution, which is y equals -1 again, so I got a 1 there. And then my volume is going to be pi times the integral from a to b of big R squared minus little r squared dx. Okay, so I'll have pi times the integral of big R squared minus little r squared dx. Big R is x squared plus 1. So I'll have x squared plus 1 quantity squared minus little r is just, excuse me, hiccups, just 1 quantity squared, and then everything here is x's, so I check my x-axis for my bounds, right? That'll complete my integral. So I'm going to just go from 0 to 1, okay? And I know you guys know how to integrate, so we're just going to spend most of the time just doing setups. Okay, the next one is y equals x and y equals x squared about y equals 1. So y equals x and y equals x squared intersect at both x equals 0 and x equals 1. So let's say y equals x looks like that, and y equals x squared looks like that, and this is my original region. And I'm revolving it around y equals 1, which is right here. Okay, and so I'm going to have symmetry over that line. All right, so I'll have this, and then I'll have that thing. This is my original region, which is important to note. Okay, you're going to draw to find, now, do you guys see how there's this gap here? Here's my original region, here's the axis of revolution. I have this, like, empty space where my finger can go or my pen point can go. That means it's a hollow solid. Okay, so I'm going to need a big R and a little r. I'm also going about a horizontal line. It's parallel to the x-axis, my axis of revolution, so everything is going to be dx. All right, so we're going to figure out what big R and little r are. Draw from the axis of revolution to the outer curve on the original region. So the original region is down here, so I'm going to draw down to it this time. I think I drew up last time. No, I drew down last time too. Okay, no, I drew up. It's okay. So we could draw up or we could draw down. It depends on the situation. So big R for that, and then little r is axis of revolution inner curve on the original region, so that's little r. Okay, now big R, I'm going to do top minus bottom. So it's touching on top the line y equals 1, and on bottom it's touching the parabola y equals x squared. My little r on top is touching the axis of revolution y equals 1, and on bottom it's touching that line y equals x. So I'm going to have my volume is going to be pi times the integral of big R squared minus little r squared with a dx at the end because I'm going about a horizontal axis. This is going to be a 1 minus an x squared quantity squared minus a 1 minus x quantity squared. All right. So now with this, everything here is x's. I need to figure out my bounds. I'm going to check the x-axis for my bounds, and y equals x and y equals x squared intersect at 0 and 1. So my bounds are from 0 to 1. Okay, just a note, if I was going to have to integrate this by hand, I'd have to FOIL this out and FOIL this out, and then I would want to combine my like terms before I started actually integrating. Okay. Next one is number 3. Same region, but a different line to revolve around. Okay, so I'm going to graph y equals x and y equals x squared down here. Okay, and I want to go about y equals 2 this time. So there's just an extra gap. All right, so this is my original region. Okay, and then I have this 1 unit gap here, so I'm going to have a 1 unit gap here, and then I'm going to come in and have that weird shape on the other side, and it looks kind of like so. All right, I'm going about a line parallel to the x-axis, so it's definitely going to be a dx situation. I need everything in terms of x. It's definitely hollow. You guys could see there's my original region. There's the axis of revolution. There's a huge gap in there. Okay, so it's going to be hollow. So now I need to figure out what big R and little r are. All right, so again, you draw from the axis of revolution, which is y equals 2 this time, up, down, left, right, but to the outer curve on the original region. I'm drawing down again. That's big R. And then axis of revolution to the inner curve on the original region. That's little r. So big R is touching on the top, y equals 2, and on the bottom it's touching the parabola, so minus x squared. Little r on top is touching the axis of revolution, y equals 2, and on bottom it's touching the line y equals x. And so here my volume is just going to be pi times the integral of big R squared minus little r squared dx. Everything is x's, so I'm going to use, oh, I'm sorry, I'm skipping ahead. I got to fill this in. So big R is 2 minus x squared, quantity squared, minus little r is 2 minus x, quantity squared. Okay, and everything here is x's, so again, I'm just checking x-axis for bounds, and y equals x and y equals x squared still intersect at 0 and 1, so I'm still integrating from 0 to 1. Okay? All right, moving on to number 4 from your worksheet. Okay, 4 and 5 are very similar, just like 2 and 3 were very similar. So I said under x equals y squared and above y equals 0 from x equals 0 to x equals 1. So we're talking about, I'm supposed to go about x equals 1. All right, so x equals y squared is a sideways parabola. So I'm talking about this thing here. And I'm only going to draw the top part because it says under this, but above y equals 0, which is the x-axis. So I'm talking about this little region in here, and I'm supposed to go from 0 to 1. Okay. And it says to revolve it around x equals 1, so I'm going to revolve it right around there. All right. And you guys see how there's no gap this time. Here's my axis, here's my original region, here's my axis of revolution. They're touching each other, so it is a solid shape. You will sometimes get solids on here. All right, the other side of it would just look like this, and it's going to be, I'm not really helping right now with what that looks like, but it's definitely solid, so I just need 1r. Now I'm going about a line that's parallel to the y-axis. It's a vertical rotation, so it's going to be a dy situation. All right, so when I draw, I just need 1r. I'm going to draw it from the axis of revolution, which is now this line y equals 1. I'm going to draw to the outer curve on the original region. So it's not up, it's not down, it's not right, it's left this time. So there's my r. Okay, and what's r touching on the right? On the right, it's touching the axis of revolution, which is what x equals 1, minus what's it touching on left? It's touching on the left this parabola, x equals y squared, and everything needs to be terms of y, so I want to keep it like that. And now my volume is going to be pi times the integral of r squared dy, because it's a vertical axis. So 1 minus y squared, quantity squared. Now everything here is y, so I check my y-axis for my bounds, and x equals 0 to x equals 1, this is also going from 0 to 1 on the y-axis. Okay, right, because it's x equals y squared. So when x is 1, y is 1. So I'm going to integrate from 0 to 1, and that's it. Okay, and then very similarly, I took the same region, and now I'm revolving it around x equals -1 for a very different visual. All right, so we're going to go that way. So I'm still talking about this little shape in here. Okay, x equals y squared, above y equals 0, from x equals 0 to x equals 1, which is also from y equals 0 to y equals 1. But now I'm going to rotate it about this line, x equals -1. That's where I'm going. Okay, so it's still vertical rotation. It's a line parallel to the y-axis that I'm rotating about. So everything's going to be in terms of y. All right, I can see that there's a huge gap between my region and my axis of revolution. So it's definitely going to be hollow. So I'm going to need big R and little r. Okay, big R, I'm going to go from the axis of revolution to the outer curve on the original region. So it's going to go all the way out here, and that's going to be big R. Okay. And then little r, I'm going to draw from the axis of revolution to the inner curve on the original region, and that's little r. All right, and then you either do top minus bottom or right minus left. So in this case, it's going to be right minus left. So on the right, it's touching x equals 1. And then on the left, it's touching the axis of revolution, which is -1. So I have 1 minus -1, or 2. For little r, on the right, it's touching my parabola. Oh, that should be x equals y squared, not y equals x squared. I apologize. Okay, so it's touching my parabola, x equals y squared. And then on the left, it's touching the axis of revolution, which is that -1. So I really have a y squared plus a 1 here. Okay, and then my volume is going to be pi times the integral of big R squared minus little r squared dy, because it's a vertical axis. All right, so I'm going to do 2 squared minus y squared plus 1 quantity squared. And everything here is y, so I check my y-axis for my bounds. So I'm just going to go from 0 to 1. Okay. Do you guys see how on this one I didn't even I didn't try to make it look three-dimensional. This is really what you need. Okay. And I'm okay with taking the pressure off of some of you guys that are getting freaked out about trying to draw these solids and they're not looking the way that you want them to. This is also very effective. Okay. Good luck with your homework.